The algebra of matrices, Cramer's rule. What are they? Matrices are an array of numbers. Why? Helps encrypt data for security purposes. Interesting fact, polar bears have black skin, and although their fur appears white, it is actually transparent. Now, let's see what Cramer's rule is all about. We have a system of equations, and we can use Cramer's rule to find our solution. Since we only have two variables here, it might be easier to graph, use substitution, or even use elimination. But when we have more than two variables, it might be easier to use Cramer's rule. Cramer's rule is x is equal to the determinant sub x over the determinant of the coefficients, and y is equal to the determinant of sub y over the determinant of the coefficients. Now, let's take a look how to find each determinant. Let's start with the determinant in the denominator. We have all the coefficients, or the numbers in front of the x's and y's. Next, let's look at the determinant in the numerator, or the determinant sub x. The second column is the same as the determinant of the coefficients. We have changed the elements in the first column from the coefficients in front of x to the constant or the k terms. Since we are solving for the x point in our ordered pair, we have changed the first column of the determinant of the coefficients, and that is the x point of our ordered pair. What do you think the y point of our ordered pair will be? Let's find out. Let's start with the determinant in the denominator. We have all the coefficients, or the numbers in front of the x's and y's. Next, let's look at the determinant in the numerator, or determinant sub y. The first column is the same as the determinant of the coefficients. We have changed the elements in the second column from the coefficients in front of y to the constant or k terms. Since we are solving for the y part in our ordered pair, we have changed the second column of the determinant of the coefficients, and that is the Cramer's rule. Now, let's take a look at the examples we're going to be discussing in today's video. Let's take a closer look at example 1. Let's read the steps. Step 1, follow the formula. Step 2, follow order of operations. Now, let's read the question. Use Cramer's rule to solve the system. Our first equation is 2x plus 3y is equal to 6, and our second equation is negative 5x plus 2y is equal to 4. Our first step is to go ahead and write down the determinant of the coefficients, and our first row is 2 and 3, and our second row is negative 5 and 2. Now, we're going to write down the x point of our ordered pair, and the determinant on the bottom is the determinant of the coefficients. The determinant in the numerator, or determinant sub x, has the second column of the determinant of the coefficients, and we have replaced the first column with the constant terms 6 and 4. That is the x part of our ordered pair. Let's write down the y part of our ordered pair. The determinant in the denominator is the determinant of the coefficients. The determinant in the numerator, or determinant sub y, has the first column of the determinant of the coefficients, and we've replaced the second column with the constant terms 6 and 4, and that is the y part of our ordered pair. Now let's simplify what we have so far by beginning with the determinant of the coefficients and multiplying 2 times 2 and subtracting 3 times negative 5. And now we have 2 times 2 minus 3 times negative 5. 2 times 2 is 4, and minus 3 times negative 5 is positive 15. And now we have 4 plus 15, and the result of that is 19. And that is the determinant of the coefficients. Now we're going to find the determinant sub x and multiply 6 times 2 and subtract 3 times 4. And now we have 6 times 2 minus 3 times 4. And 6 times 2 is 12, and minus 3 times 4 is minus 12. And now we have 12 minus 12, and the result of that is 0. And now we're going to divide 0 and 19 to find the x part of our ordered pair, and 0 divided by 19 is 0. And now we found the x part of our ordered pair. Now let's find the y part of our ordered pair by finding the determinant sub y by multiplying 2 times 4 and subtracting 6 times negative 5. And now we have 2 times 4 minus 6 times negative 5, and 2 times 4 is 8, and minus 6 times negative 5 is positive 30. And now we have 8 plus 30, and the result of that is 38. And now we're going to divide 38 and 19 to find the y part of our ordered pair, and 38 divided by 19 is 2. Now we have our two parts of our ordered pair. Let's put them together, and 0, 2 is our answer for example 1. Now let's move on to example 2. Let's read the question. Use Cramer's rule to solve the system. Our first equation is 2x plus y is equal to 3. Our second equation is negative 2y plus 3z is equal to 1. And our third equation is 3x plus 4z is equal to 0. Now, let's write down the determinant of the coefficients. Our first row is 2, 1, and 0. Our second row is 0, negative 2, and 3. Our third row is 3, 0, and 4. Let's write down the x part of the ordered pair. We don't have room to write down the determinant of the coefficients. That is why we just have the symbol. Since we are solving for the x part of the ordered pair, our first column has been replaced with the constants, or 3, 1, 0 in this case. And the other two columns are the same as the determinant of the coefficients. Let's write down the y part of our ordered pair. Since we are solving for the y part of the ordered pair, our second column has been replaced with the constants, or 3, 1, 0 in this case, and the other two columns are the same as the determinant of the coefficients. What do we think the z part of our ordered pair is going to be? We haven't seen it yet, but it follows the same pattern. Let's write it down and see. Since we are solving for the z part of the ordered pair, our third column has been replaced with the constants, or 3, 1, 0 in this case, and the other two columns are the same as the determinant of the coefficients. Now, let's simplify what we've done so far by finding the determinant of the coefficients. Which row did we use to break down the 3 by 3 matrix? Let's find out. The remaining elements, negative 2, 3, 0, 4, are used to create the first determinant after covering the first row and first column. The remaining elements, 0, 3, 3, and 4, are used to create the second determinant after covering the first row and second column. The remaining elements 0, negative 2, 3, and 0 are used to create the third determinant after covering the first row and third column. And that is our first step in finding the determinant of the coefficients. Let's simplify what we have so far by finding the first determinant. We are running out of room here, so if you could put the steps in the comments below, that would be awesome. The first determinant is negative 8, the second determinant is negative 9, and the third determinant is 6. And now we have 2 times negative 8 minus 1 times negative 9 plus 0 times 6. Let's go ahead and simplify what we have so far. And 2 times negative 8 is negative 16, minus 1 times negative 9 is plus 9, and 0 times 6 is 0. And now we have negative 16 plus 9 plus 0, and the result of that is negative 7. And that is the determinant of the coefficients. Let's find determinant of x. And determinant of x is negative 28. Which row did you break down the 3 by 3 matrix? Put it in the comments below. That would be superb. Now we need to divide negative 28 by negative 7, and the result is 4. That is the x part of our ordered pair. Let's continue by finding the y part of our ordered pair by finding determinant sub y. And determinant sub y is equal to 35. Which row did you break down the 3 by 3 matrix? Put it in the comments below. That would be awesome. Now we need to divide 35 by negative 7, and the result is negative 5. And that is the y part of our ordered pair. Let's continue by finding the z part of our ordered pair by finding determinant sub z. And determinant sub z is 21. Which row did you break down the 3 by 3 matrix? Put it in the comments below. That would be great. Now we need to divide 21 by negative 7, and the result is negative 3. That is the z part of our ordered pair. And now we have all three parts of our ordered pair. Let's go ahead and put them together. And that is the answer for example 2, the point 4, negative 5, negative 3. Now it is your turn, so go ahead and pause the video so you can take your time to answer this question, and I will show you the result in 3, 2, and 1. If you got it correct, well done. If not, there's always tomorrow.